Hello everyone, this is Najib Hassan and I am going to report about the integration and sum application in Chapter 4, Beamer 8 areas. So in this chapter, we shall discuss the following concepts. Number 1 is the concept of derivative and the relationship between integration and differentiation with respect to a class of a function. So in this chapter, we are going to study the difference between integration and the differentiation. And we know that integration, it is the process of bringing smaller components into a single unit that acts as one single components. And the differentiation, it is the process of determining the rate of change in quantity with respect to another quantity. Number 2 is the some useful theorems on integration, and number 3 is the partition of a closed interval. Number 4 is the Riemann sum and the Riemann integral. So in this chapter, we will also review to study about the Riemann sum and the Riemann integral. So we know that the Riemann sum, it is used to approximate those areas, and the Riemann integral, it is used to represent the exact area under a given curve. So lastly is the some applications of the Riemann integral, such as the computing the measure of an area of a region, the measure of a volume of a solid, and the measure of the length of an arc. Theorem: let f of closed integral a and b is equals to any real number be a continuous function on a closed integral a and b, and suppose that f of x must be greater than or equal to 0 for all x on a closed integral a and b. Let R be the region bounded by the curve y is equals to f of x, the x negative axis, and the lines x is equals to a and x is equals to b. Then the measure a of R of the area of the region R is given by. So this is the notation. So a of R is equals to the limit of the summation of f of epsilon sub I times the difference of the x sub I minus x sub I minus 1 as I from 0 to n is equals to the integral of f of x and the closed integral b and a with respect to x. So example number 1. Find the area of the region bounded by lines y is equals to 2x plus 3 as x is equals to negative 1, x is equals to 1, and the x negative axis. So this is the solution. So we need to sketch the graph. Sketching the graph of the region R, it is bounded above by the line y is equals to 2x plus 3 and bounded below by the x negative axis, or the line y is equals to 0, bounded to the left by the line x is equals to negative 1, and to the right by x is equals to 1. So by this equation or this given, we can easily determine the bounded below, which is the x negative axis or the line y is equals to 0. So it is bounded to the left when x is equals to negative 1, and it is bounded to right when x is equals to positive 1. So by the given theorem above, the measure of the area of the region is a of R is equals to the integral of 2x plus 3 and the closed integral of 1 and negative 1 with respect to x. So ito yung previous theorem natin na discuss, which is yan yung the integral of f of x, the integral of f of x and the closed integral of b and a with respect to x. So yan yung pinag-aralan natin na theorem. So a of r is equals to this integral. So first is So yung 2x plus 3, yung 2x plus 3 is yung 2x is equal lang siya sa x squared. Kasi yung 2x na ang antiderivative niya is x squared. And yung derivative ng x squared is 2x. Kasi if i-transfer natin yung 2 dito is 2 times 1 would be 2 and yung 2 minus 1 would be 1. Kaya equal lang yung 2x at saka x raised to 2. So, yung constant natin na 2 is mailabas na siya sa mailabas yung number natin na 2, yung constant natin na 2, kaya siya yung mag-cancel out dito sa denominator natin. Kaya matira lang is x raised to 2 plus 3x. Yung 3 is equal lang din siya sa 3x. So, after that is we need to substitute the 1 to these x variables to get 4. And negative 1, we will also substitute this negative 1 to this variable and we will get negative 2. And to simplify this is we will get 6. To compare this result to example 1 in partition, see Beamer 7a, that is to see the Riemann sum, where the summation of f of epsilon sub I times the difference of x sub I minus x sub I minus 1 as I goes from 1 to n is equals to the summation of f of epsilon sub I times the delta sub I of x as I goes from 1 to n is equals to the f of epsilon sub 1 delta sub 1 of x plus f of epsilon sub 2 times the delta sub 2 of x plus the f of epsilon sub 3 delta 3x plus f of epsilon sub 4 delta 4x. So 3 over 4 plus 5 over 4 plus 7 over 4 plus 9 over 4 is equals to 24 over 4, and we will simplify this. We will have the answer of 6.